Here, let's have a look at using Newton-Raphson then to solve this particular equation here. So we've got to solve this. When does this equal 5? Not the sort of equation you'd want to try and solve without using some sort of numerical method like this. To use Newton-Raphson, the first thing to recognise is that one side, in this case the easiest one is the left-hand side, must equal 0. So it's got to equal some function equal to 0 to work. And so the first thing I'm going to do is to write down the function equal to 0. So 5t to the 4 minus 3t cubed plus e to the 4t minus sine t minus 5 equals 0. So I'll bring everything over to one side and make it equal to 0. And then I'm going to use Newton-Raphson. R stands for the root. So my answer, my guess, R is the answer. R is the value of t such that this left-hand side equals 0. And I'm trying to find out what that is. Each R2 and R1 stand for root 1, root 2, root 3, root 4. So guess 1, guess 2, guess 3, guess 4. So we guess an answer. We guess that t equals something. And then work out what a better guess is. R2 is a better guess. And this method allows us to do that. And then we use R2 as our R1 and repeat the process. So we let our better guess equal R1, work out what the right-hand side is, more on that in a minute. That gives us R3, or an even better guess, and so on. We keep going until we've got it to an appropriate accuracy, 2 significant figures, 3, something like that. In the exam we will tell you how many significant figures to go to. I've plotted this function on an autograph. Here it is. And so I know that my answer is around about 0.4, something like that, 0.5. So what I might do on autograph is to zoom in, actually. And I could get the root that way by zooming in gradually on the screen. I know it's between 0.4 and 0.5. So let's just put that in our notes. I know it's between 0.4 and 0.5. In fact, let me have another go at that. So I know the root lies between 0.0 and 0.5 because I plotted an autograph. But without something like this, what I would do, my first thing would be to put some values in. Let x equal, or in this case t equal, a value, and see whether or not the answer is negative or positive. The root is positive, or the value of the function rather is positive at this point, negative at this point. So if I put in t equal to 0.4, I'd end up with a negative root, or a negative value for the function rather, if I let r equal 0.4. If I let r equal 0.5, I'd end up with a positive answer for the root, for the function rather. So in other words, if I let t equal 0.4, 0.5, let it equal 0.4, I'd have a minus answer. Let it equal 0.5, I'd have a positive answer. So the correct value for it equal to 0 must be somewhere between 0.4 and 0.5. So I could pick 0.45 as my start point, as my first guess. But if I've done it, if I've worked out the function, and I've found out that actually the value of the function is smaller, it's this negative answer here will be a bit smaller than this positive answer for 0.3. I mean, that's up here somewhere, isn't it? And so I guess if that's a bit smaller and that's bigger, it's got to be nearer to the 0.4 than 0.5. So I might, the better your first guess, the less iterations you have to do to get an accurate answer. So, you know, make it a good guess. So say 0.3, 0.2, something like that. Sorry, 0.42 would be my first answer. So I'm going to let R1 equal 4.2. My guess, okay, my first guess. And now I use Newton-Raphson. Let's look at it for a minute. So I now know what R1 is, it's 0.42.
exam or not. We obviously won't have that, but we'll be told what the root was.
Yes, you'll be given a good idea as how to arrive at your first guess. Yeah, and then you, along the lines of we've just been discussing, really. Okay. Without me giving you a picture, I could sort of put it in words, couldn't I? That's probably what I'll do. But it'll be obvious. Now, what does the rest of this Newton-Raphson mean? F. F is the function. So the function is this. So F is 4t to the 4 minus 3t cubed, or there should be a plus there, plus e to the 4t minus sine t minus 1. That's the function. R1 means what's the value of the function when r for the value of 0.42. So I work out what is the value of the function at 0.42. If you remember your differentiation notation, f prime means the first differential. So f prime means the differential of this function. So to use Newton-Raphson, I need to differentiate the function. So what I do is, to use Newton-Raphson, I put in 0.42 in my calculator, and then I subtract the function when x equals, or t in this case equals 0.42, and divided by the differential at 0.42. So what I do is, I take my function, so I've got to rewrite this again, and now I say the function equals 5t to the 4 minus 3t cubed plus e to the 4t minus sine t. That's the function, so that's f. Am I reading that correctly?
Yeah, minus 5.
Minus 5, thank you, minus 5. Minus 5 at the end. Thank you. And so now differentiate it. And I just go through each term, differentiate it. So bring the power down, times your other number in front, take 1 off the power, 20t cubed, minus 9t squared. If for an exponential function, the 4 comes down, but the rest stays the same. And sine goes to cosine, so it'll be minus cos t. And then 5 constant disappears. So that's the differential. And now I write down what R2 is. It's going to equal 0.42, which is my R1, minus the function for R1. So it'll be 5 times 0.42. I'm going to run out of room here. 0.42, isn't it?
Yeah.
Leave yourself plenty of room, because it can get quite long if you're going to write it down. 5 times 0.42 to the power 4 minus 3 times 0.42 to the power 3 plus e to the 0.42 times 4 minus sine 0.42 minus 5. There's a reason why it's worth putting the 0.42 in brackets that I'll show you in a minute. And write it exactly like this that I've done on the board, because that's what you're going to type into the calculator, divided by the differential. 20 0.42 cubed minus 9 0.42 squared plus 4e to the 4 times 0.42 minus cos 0.42. And now I type that into my calculator, so just pause this while you do that.
put times and
Okay, well, so that's what I put in. I'm not sure whether or not you need the times or not outside the bracket, maybe not, but I'll possibly put that in. It's not incentive to put the bracket in, you could just put times 0.42 and then cubed. And I think that's the answer you get. Now, once you've done that, so assuming that's worked and you've got this answer, and if it hasn't worked, it's possibly your calculator hasn't got enough capacity to put this in one hit, in which case you have to do it in bits. But in the exam, it's not going to be such a long function as this, so you should be okay. What you do is then scroll back on your calculator, and every time you put 0.42 in to your original calculation here, every 0.2, including this one, don't forget the first one, you replace with answer. And then you just keep having to hit the equals button on the calculator, and each time you do that, you can replace the original R2 with the x1 and so on. So if I were to scroll back now and replace all the 0.42s with the number with answer, using the answer button, it would really allow me to zoom in on the final value. So pause while we have a look at that. Yeah, so on my calculator I get this at the end, and actually it sticks on that, so it's giving me the same answer to 1, 2, 3, 4, 5, 6, 9 significant figures. So, but in the exam you'll be asked to quote it to say 2 or 3 significant figures. So show the working as far as at least the second iteration, and then you can use the calculator from there onwards if you want. So in Rapheson, a really useful way of finding the root of an equation. The key things to remember are that the original function must equal 0. So if you're given this as a start point, make sure one side equals 0. So shift the file over, and then the function here is going to equal whatever that is. And then you differentiate it.